So today we're going to talk about what a function is. And I know it sounds kind of strange right now, but a function is one of the most important things that you will take with you from this class into all of your math classes at the high school. Okay. We talk about functions often, and even on Thursday, we're going to talk about a special notation for a function. Okay. So there are a lot of different ways that we can represent a function, but first let's talk about what a function is. Okay. A function, and I want you to write this with me, is a relation where each input has one output. Write it down. Let's talk about what that means. So there are four different ways. Well, yeah. 5 different ways we're going to talk about representing a function. Okay. The first one is by an equation. You've seen equations. Y equals X plus 7. That is an example of a function. Okay. We're going to talk a lot about what this graph specifically looks like. Okay. You could represent a function by an input-output table. Okay. So you have an X and a Y. Okay. Now let's come back to this like input-output. When we're talking about a function, when I say input, that's like X. And our output is like a Y. All right. We're going to plug in numbers for X, and it's going to give us an output. Okay. Like if I plug in X equals 2, then I get out Y equals 9. That's why we call them inputs and outputs. Okay. And a function, there's only one, each X only has one Y. All right. And we're going to talk a lot more about that. Okay. A graph. Okay. We might have a graph where we have to decide if we have a function or not. Okay. We could also have a set of ordered pairs. So like here is like our input-output table. The set of ordered pairs would be 1, 2, 3, 4, 5, 6. It's the same coordinates, just written X, Y, X, Y, X, Y. So it's not a letter, it's like a brace. Like a brace. A bracket would look like this. Okay. So are you a musician, Brooks? No. Okay, because that would be called like a brace if we're talking about the treble and bass class.
I used to play trombone.
You were used to. Wait, I never even knew that. I was a saxophone player back then.
Okay. We also have something that's called a mapping, where we have our X's and our Y's, and we have arrows drawing the X to the Y. So like the 1 is being mapped to the 4. so I know my coordinate is 1, 4. The 2 is being mapped to the 5, so I know my coordinate is 2, 5. See what I'm saying there?
So you just add 3 to it?
Okay.
So 1, 2, 3 would be the input, the y.
Yes. It's like this, but I have error. So okay. So since I have an arrow from 1 to 4, I would have the coordinate 1, 4. And since I have an arrow from 2 to 4, I have the coordinate 2, 4. And since I have an arrow mapping 3 to 5, I have the coordinate 3, 5. That's what that would mean.
What happened to the 6?
I changed it so that you could see better. Okay.
And output, is it always like similar to with graphs?
Yes. Yep. So it's like X's are the input, Y's are the output. Okay. So now, in order for us to say, hey, this is a function, every input has to have one output. So I want you to look at this graph right here. This is the coordinate 0, 8 and the coordinate 1, 6. Blah, 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 blah. Does this represent a function? Does each input have one output? It does. Okay. Let's go ahead and write out all of the coordinates. What's that first coordinate? What did I say? 0, 8?
0, 8.
Okay. What's the other one?
1, 6. 1, 6. My bad.
Then
2, 4. 3, 3. And 4, 6.
okay. So what I notice is that every X has one Y. If I had an X that had 2 different Y's, that would not be okay. Hey, do you have something for me? Thank you. Okay. Please get this signed tonight and bring it back to me. What? It's 3, 2. Oh, who told me 3, 3?
Henry.
Henry.
Wow, what are you supposed to do?
Yes. We'll see. Okay. That will be good to know. Tomorrow, sit there and then we'll just. Okay. Now, notice how every X has one Y. Okay. In this guy right here, does every X have one Y? Okay, yes. Okay, so this is a function. Each X has one Y. This is a function. Okay. Do you not like that?
I'm not a big fan of the mouse.
Okay, Brooks, what about B? Does every X have one Y?
No. No, all the X's are the same.
So what you're saying is I have one X that has 5 Ys.
Yeah. Then you can say the same thing for the first one.
No.
No, no, no. Because it's not the input.
The input of 0 has an output of 8. The input of 1 has an output of 8. So the outputs can be the same, but the inputs cannot repeat. Okay, no. 8 has more than one Y.
Would it be output as Y?
What?
What output too?
Yes, you could say output. Quarter now. Thanks, Harry.
More than.
One Y.
No. Oh, we can talk about it later. Okay, let's go to the next page. Here we have a mapping. Here we have a mapping. Yes or no? Is this a function?
No.
Yes.
I'm hearing some yes, I'm hearing some no.
No. Yes.
Okay, I can, just for you. A function means every x has only one y.
No.
Okay.
No.
So Connor, I want you to look up here. Does one, is it mapped to only one y? Is x equals 2 mapped to only one y? Is x equals 3 mapped to only one? Okay, so this is a problem right here. No, this is not a function because x equals 3 has two different outputs. Okay, not a function. Okay, I would like you to chit chat with your neighbor about what you think about D, function or not function.
No, because
Yeah. Is there too much tension between you two?
I don't know.
You're sitting right next to me.
Okay. All right, eyes up here. Okay. Harry and Allison, do you think this is a function or not a function? Harry and Allison, why do you think this is not a function? Well, you're right. So you have a good theory, Kyron.
Because 5 has 2 outputs.
Do you agree? Okay. So he is true. He is true. He is correct. I want you to write something down called the vertical line test. If we have a graph, okay, so the vertical line test is going to help us determine if we have a function based off of our graph. So do you notice how Kyron mentioned that x equals 5? Okay, if I draw a vertical line and if it goes through more than once, then it's not a function. So this is not a function because it fails the vertical line test. Okay, so you could draw a vertical line through x equals 5. You could draw a vertical line through x equals 7. Either way, it fails the vertical line test. It only has to happen once for it to be, nope, not a function. Okay. So this might be a helpful visual if you have coordinates just in like an XY table. Okay. And you're not really sure if it's a function, not a function, you can think about graphing them. Are they going to stack vertically on top of each other? DJ, do you need something, bud? No? Okay. All right, so let's talk about E and F. I'll zoom in on E. if these 5 coordinates are they a function or not? How about you give me a thumbs up or thumbs down? Yes, a function, not a function. Okay, Brooks, what's the problem?
There's 2 6s for the Y's.
Okay, but our rule is, let me just repeat the rule. Every input has 1 output. So every X has 1 Y. Do we have an X that has 2 Ys?
No.
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 Wow, Jerry. I see how it is.
Maybe like read it.
Okay, so Brooks, you are not my only thumbs down. Okay. -2 only has 1 output. -1 only has 1 output. This is what it would look like if we did not have a function. Think about this right here. Notice how -1 has 2 different outputs. Oh, that's the only one. Okay. Notice how -1 has 2 different outputs. Right here. No, this is not a function. Because -1 has 2 outputs. Okay. So like I said, maybe you really like that vertical line test. Maybe you could think about graphing these points. Ooh, these 2 points right here, they're going to be vertical from each other. We're not going to pass the horizontal line test. But if we come over here to E, if I plot all of those points, none of them are going to be vertical from each other. So we're going to be okay. These 2 points, they're going to be horizontal from each other, Brooks, but that's okay. We can be horizontal from each other and still pass a vertical line test. Okay. Okay. All right. Let's go to page 61. Okay. And we're going to write down 2 different, 2 definitions. Did you just ask when we get new seats? Write this down. Relation. Pairs of inputs and outputs. A relation is just saying, hey, here are my X's and here are their Y's. And we can do that in 5 different ways. We can write an equation. We can have an XY table. We can have an XY map. We could have a graph, or we could have a list of ordered pairs. Okay. A function, and I'm going to make you write this again to get it through your brains. Okay. We have a special relation. Each input has 1 output. Our X's can't repeat because then that means it has more than 1 output. Not like, is it a function? Is it not a function?
I'm saying there's some like trying to
There you go.
just go to the movie theater.
So will we be doing word problems eventually? But the really the biggest thing is like we're going to be using function notation, which I'll teach you about in a couple days. Okay.
It's kind of confusing.
we're gonna spend we're gonna really like spend a lot of time like getting used to this, okay? So functions are really important for us as we go through like higher mathematics. So right now we're getting like a foundation so we can use the concept as we go through for a lot of different things. Okay. All right. So this is what I need you to do. What? Okay. Thank you for asking me yourself instead of having your friend do it. What I would like you to do is go to page 63. And I want you, you know what? No. Okay. You and your elbow partner. So you might have a new one right now. You and your elbow partner need to determine function, not a function. Function, not a function for each of these four.
No.
On the board. What size? Is that better? Does it pass the vertical line test? Then
Yes. Right. No. Yes.
I'm getting no, yes, yes.
What do you think?
what do you need, Kaylee?
There's no markers on our table.
That's disappointing.
Yes, yes.
No, number 3 is a yes.
You're just talking about it. What did I tell you to do for a graph?
Number 1 is no. No, it's yes.
I got
No, there's -1 for 4. -1,
Actually, no.
First and the last one. Number 1.
Yeah.
They're both -1, but they have different outputs.
Oh.
So no, and then 2 is yes, and then 3 is no.
All right, eyes up here. Kaylee and Drew, is number 1 a function or not a function? Why?
Because it's 2 -1s.
Okay, so the input of -1 has 2 outputs, right? Okay, great. Number 2, Henry and Ellery, function or not a function? Why? Because it
Doesn't have any Y's in it.
It passes the vertical line test. Okay. All right, number 3, Connor and Ian, function or not a function?
Not a function.
Yes, it is.
No, -2 has.
-2 is 1x and it is 2 y's. But that's a y. Shut them down. Shut them down.
So like if we write these down, this would be -2, 9, -2, 2, and -1, 1. So I have 2 different x's. Or I have 1 x that has 2 different y's. That's not okay. All right. All right. Excuse me. Can I? Okay. Maddie and Ella. What do you think for number 4? Function?
In the wrong direction.